Welcome to another video. In this system of x-seq equations, let's see how to find the x. So given this, by transferring 2 to the left hand side, we have everything equals 0. And looking at this, you can write this as x to the power 3 or x to the power 2 minus x raised to the power 3 minus 2 equals 0. And so there are two things involved here. Let's say we have like two methods of doing this. If you compare this with this quadratic equation, which is ax squared plus bx plus c equals 0, or you can just let x squared to be any other alphabet direct and solve it quadratically, or we do it this way as well. So suppose we now choose x cube instead of x, then we have minus 1 plus or minus the square root of minus 1 square minus 4, then a still remains 1 and the value of c is minus 2, all divided by 2a, which is 2 multiplied by 1. So the expansion of this is 1 plus or minus the root of 1 square is 1 plus, and the whole of this is 8 divided by 2. And the next thing is we have x cube equals 1 plus or minus, here is 3 divided by 2, and x cube equals 1 plus 3 is 4 divided by 2, or I leave it like that first, then the second one goes with negative. Therefore x cube equals 2, or we have minus 1. But what we need here is we need all the 6 roots. So for the case 1, which is x cube equals 2, to solve this, we transfer 2 to the left hand side and we have x cube equals minus 2 equals 0. And we can write this 2 as minus the cube root of 2 and all to the power of 3. Everything equals 0. And considering this, we have x and cube root of 2 all taking cube. By comparing it with this, suppose we have a cube minus b cube. This is equivalence of a minus b bracket, we have another bracket which is x squared plus ab plus b squared. This is just like the difference of 2 cube. By replacing it here, we have x minus cube root of 2 bracket, while the second one is still x squared plus we have cube root of 2 then x plus the last one, which is cube root of 2 all is taken square. Then we bracket everything. So for the first side here, for the first one, if all this equals 0, for the first one, we are going to let x minus cube root of 2 equals 0, or the other part equals 0. But if you have this, which is x minus cube root of 2, the whole of this equals 0. And this one, I don't need to do it, because so what I will get here is the complex root. Though I can try to solve it and get the complex root, but let's say I limit myself to only the real value of x. So which means we are going to ignore that one and deal with this, which is x equals cube root of 2. So this is how I got the first value of x. So while for the second case, which is x cube equals minus 1, you can also do that by doing saying x equals minus 1 and x cube plus 1 equals 0. So you can write this as x cube plus 1 cube equals 0, and Again, we are going to try this identity, which is a cube plus b cube, which is equals a plus b bracket x square minus ab plus b square. We call this sum of two cube. By replacing it, we have x plus 1 bracket x square minus x plus 1 equals 0. So therefore, for this, we are going to have a complex root as well. So therefore, we have x equals x plus 1 equals 0 and x equals minus 1. So this is how this other root is gotten, provided that I've neglected the complex root. So the two real roots are minus 1 and the cube root of 2. So which gives the solution to this. So we can test it when we plug it in these equations, and the left hand side will be equals to the right hand side. Thanks for watching, and please don't forget to subscribe for more exciting videos like this. See you in the next class. Bye bye.